Hello, my dear students. Today we are going to learn about a numerical on back propagation algorithm. So, it is a very important algorithm in deep learning to understand the further processing of all the subsequent architecture that we are going to learn. So, what we are going to learn is that how do we feed forward, evaluate the outputs on every neuron, and then how do we back propagate and update the weights and then the next cycle. So basically you can see that this is a very small architecture in which we are having two inputs, one hidden layer, and in that hidden layer we are having two neurons and a output neuron. In this, all the weights are already given and the possible inputs are already given. So this is my output that is notated by tau. So for 1 1, my expected output is 0. For 0 1, my expected output is 1. Now all the denotions in this diagram is already done, that you can see. Everything is given. Learning rate will be 0.5, the training tuples will be 110 and 011. It is already written here, and all the things are already written over here. So this is the numerical, and now we need to show that how will the back propagation algorithm will work. And in this question it is already given that we have to use or assume that we are going to use sigmoid activation function. Okay, this is just a numerical, that is why we are using this activation function. Otherwise the activation function depends on what you're going to solve. Now you can see that in my slides everything is given. So let's start with the evaluation for the this neuron and this neuron, which are basically neurons in the hidden layer. You know that these two are input, so we have taken the first row and 1 is the input. Weights are already given. Now to evaluate the output on this 3 numbered neuron, we need to evaluate the first of all weighted sum, and then we will apply the sigmoid function so that we can have some output on this neuron numbered 3. So to evaluate the weighted sum, I3 will be equal to, basically it is given I3 will be O1, this is your O1 multiplied by weight 13, and your O2 multiplied with the weight of 23 plus bias of this 3. So everything is written here, you can check, and then evaluation will give you some output. So currently we are having output for this, that is 0.8. Now for this 0.8 we need to apply the sigmoid function, basically this activation function, and then ultimately we will get the output that will be 0.69 evaluated. Alright, you can please repeat this if you didn't understood. It is basically multiplication of this input and this weight plus multiplication of this input and this weight plus the bias. Then we will get the output, and basically we are saying it is I3, and on that I3 we are applying a sigmoid function to get the O3, that is 0.69. In a very similar way we have evaluated for this neuron. First of all we will evaluate the weighted sum, and then we will apply the sigmoid function. So here also you can see that what we will do, input multiplied by this weight plus input multiplied by this weight, it is written over here, plus the bias, then we will get the weighted sum. Now the output is 0.3. On this 0.3 we will apply the sigmoid function, and then hence we will get this value. So we can say that on the hidden layer the output is 0.69 and 0.5744. Now in the next step, what we are going to do, we are going to multiply this 0.69 multiplied by 0.1 plus this 0.5744 multiplied by weight 45, that is 0.3 plus this bias. I've shown this here. So in I5, we are going to do this multiplication and then we will get the weighted sum on this neuron. Then we are going to apply the sigmoid function and we are going to get the O5 value, that will be 0.73. This evaluation you should do yourself to check that if the output is correct or not. You should understand the concept to evaluate. Now, till now you have done one feed forward for one input. Now, our question says that we need to perform the back propagation. For back propagation, we need to go back. We need to evaluate what is the error. On the basis of those errors, we will update the weights. So, let's go further. Now, you can see that we are having some error. Okay, listen, one thing that you all need to basically remember or memorize the formula, or you can see other videos where how we got these formulas. So in this video we are going to only solve the question. So I'm only explicitly telling that this is the formula. So for error evaluation on specifically output layer, the formula will be output of this neuron multiplied by 1 minus output of this neuron. This is your output tau. Tau is your output, जो हमारा expected output है, minus this O5, whatever the output was there. So the evaluation you can see, so this will be your error minus 0.1425. Take a note of this. Now, what we need to do, we need to evaluate the error on third and fourth. Remember this thing that this is your output layer and these are your hidden layers. The formula for hidden layer is different. Formula for hidden layer is output. Basically, if we are evaluating the error on this 4 numbered neuron, the output at this multiplied by 1 minus O4 output at this multiplied by error which we evaluated in the previous slide, error here multiplied by the this weight. So O4 multiplied by 1 minus O4 multiplied by error 5 and multiplied by weight of 4, 5. Alright, this you need to remember and then your error will be evaluated. Now see, to evaluate the error at this node, what you need to evaluate? O3 multiplied by 1 minus O3 and then error at this, so that will be error at 5 multiplied by this weight, so that will be W of 3, 5. Then you can evaluate the error. Now remember this thing that this is for the hidden layer. For the hidden layer, this is the formula. Now we have evaluated the errors on the neurons. But the purpose of back propagation is to change this weight, or should I say update these weights, so that we can again do the feed forward and get the desired output. So let's learn to update the weight. So formula for this is this. Now let's see how to update the weight. So let's start with the weight of 4, 5. This one. It will be weight of 4, 5, whatever the older one was. Basically what we are doing, we are going to evaluate that what we must keep the newer weight. So for that the formula is older weight plus I multiplied output multiplied the error. Here I is the learning rate, that is already given as 0.5. So let's apply this formula. So you for this weight, we need to use the older weight plus the learning rate. Learning rate is 0.5 given in the question already. Then we need to write the output at this node because we are updating this particular weight. So output was evaluated as 0.5744 multiplied by error at this node. So this was multiplied by minus 0.1425, and then we will simply evaluate this. All right. So what we have done, again I'll show you this plus learning rate multiplied by whatever the output was here and whatever was the error here. So this is how we are going to evaluate that what we must keep the newer weight. Now let's see that if we need to evaluate that what will be the newer weight for 3-5 node. So what you need to do, older weight, that is 0.1 plus learning rate 0.5 multiplied by whatever the output for this node was. So this was 0.69 multiplied by whatever the error we got here. So that is minus 0.1425. Simply evaluate this and you will get the output. Synonymously, you will apply the same formula here. So what will be the formula? Let's do it yourself. Try it yourself. You will be having the older weight plus learning rate, that is 0.5 multiplied by O2, whatever the value was here. So O2 was the input value multiplied by error at this node. This we have already evaluated. Solve this, you will get the new weight. Similarly, update the weights. Next appears. Alright. So this is how you will get the next newer weights basically. And then after the weights are updated, again do the feed forward. Check if your output is as same as the expected output what we are looking for. If these are same, then we are done. Otherwise, again back propagate, and this is how you will get, after some iteration, you will get the better weights that is able to evaluate the output synonymous to your expected output. So I hope you all got the I hope you all got the concept of back propagation numerical. Kindly do it yourself. Try solving this question in your notebook, as this is very important to understand for the future architectures that you're going to learn. Thank you.